want to get an iPad and
Yep.
do the questions via the iPad? That way they don't have to click in?
Yep,
Okay.
it's a good idea. Bless you.
What do you want?
I was scrolling through. I was scrolling through. What's up? Microsoft Teams.
Where do you want this thing?
Right there. That's what's it. You gonna do okay? You're gonna be awesome, dude.
What is it? I don't know.
Well,
It's a
you
little
see-
rose.
You seen two master
I know.
acceptance.
All right. Let me get to. Okay. All right, I'm gonna take my mask off for just a second. Bear with me. Okay, so what time is it? We're still just a little bit before 12:40, which is the official start of sixth period. So what I'm going to do is give you guys time to get logged on, just like we've done like we did last week in the other live lecture. Make sure you have something to write with. Make sure you have something to write on. Loose leaf paper, a notebook, a binder, your notes feature on your computer. Make sure you're doing that while we're doing the lecture. And then also in the live chat, go ahead and put your name and your teacher's name when you log on. That way we can kind of get an idea of who's in here. And then, I don't know, I'd say 5-ish minutes, maybe a little bit more, maybe a little bit less. We'll go ahead and get started with talking about the metric system and metric conversions. Glad you guys are here. Hang out for just a second while we get everybody logged on. All right, see you soon. I don't know why it just stopped on that last one. Weird.
You have a ton of people in this class.
Me?
Yeah. A ton.
I have huge classes, dude. All day long.
This is 18.
So far,
What's the participants?
did you put that little thing up there to block it on purpose?
What?
Your clock.
This dude's so bad.
It's so hard to see it.
You can't see the clock. I'm like, perfect.
All right, it's 12:42, so let's give it another 3 minutes to get everybody logged on. Make sure you have something to write with. Make sure you have something to write on. So you're gonna jot down some notes as we do the lecture, and then put your name, put your teacher's name. It is just Mr. Wen and my 6th period class in here today. So make sure you put your name and your teacher's name in the live chat, and we'll get started in just 2 minutes. Let's call it 2 minutes. All right, let's do it. It only says 19 in the chat. It seems like
If you don't, whatever you don't get done, remember you gotta do it at home. Take pictures of the rest.
20 something,
27.
27.
I have 13.
All right, guys, just a couple more minutes. Hang in there, and then we'll get it going. We got 21 in my 6th. Yeah, big class.
It's the 34.
34. We're getting there. All right, one more minute. Thanks to those of you that are being patient as we wait for everybody to get in here, and then we'll get going. Ready? All right, let's go ahead and get into it. Again, welcome to Mr. Ewald and Mr. Wen's 6th period classes. Today we're going to be talking about measuring using the metric system, and also talking a little bit about converting within the different units that exist within the metric system. So let's kind of dive right into it, get it going. So first off, what is the metric system? All right, so the metric system is a system of measurement that was developed in the late 1700s by the French. All right, a couple of big things about the metric system. Number one, it is based on powers of 10. All right, so it's very, very easy to use, very easy to measure using the metric system, pretty easy to convert within the different units within the metric system. It's used by, there we go. It's used by almost every single country on Earth, except for the United States of America. For some reason, we have decided at some point that we weren't going to use the metric system. So we use a completely different set of units for measuring. But today, we're going to talk about the measuring system, the metric system that's used in most places around the world, and also a lot by scientists. Okay? It is abbreviated SI, which means Système International, so SI. So you might hear your teachers talking about the SI unit for length, the SI unit for mass, the SI unit for temperature. That just means that it's a metric unit. Okay? So let's see what that's all about. Metric prefixes. Okay? So, regardless of the unit, the entire metric system is based off of using the same prefixes. Some of the most common that we're going to see are kilo, centi, milli. All right? Kilo means 1,000. Centi means 100, and milli means 1,000. So you'll see right away that these are all based off of units of 10. That's what makes it so easy to measure and so easy to convert. Okay? If you think about these prefixes, look at this. 1 meter equals 100 centimeters equals 1,000 millimeters. So when we're jumping from one unit to the next, the fact that it's built off of these units of 10 make it really easy. Now take a step back for a second. Think about the units that we use for measuring length. Okay, we have inches, we have feet, we have miles. All right, we have leagues. All of these different things that you can use to measure length. But it's pretty hard to figure out how it works. You have to know how many inches are in a foot, how many feet are in a mile, how many miles are in whatever. All right, so it can be kind of confusing to convert between those. Not the case with the metric system. I think if you don't already know it, you're going to see pretty quickly that it's really easy to measure and convert within the metric system. So let's look at this diagram. My apologies if it's a little bit hard to see, but what you should see is across the top it says the base units or the basic units for the metric system, meter, liter, gram. Right here we have our prefixes. So in this column and in this column we have our prefixes. All right, mega being the largest unit, all right, and the angstrom being the smallest unit, right? And to go from largest to smallest, we go mega, kilo, hecto, deca, and then we have our base units, meter, liter, gram, that goes here. And then we go to deci, centi, milli, micro, nano, and the angstrom. All right, so we're going to talk a lot about this. We're going to use this a lot. Do you have to memorize this, Mr. Wen?
No, you do not have to memorize it.
Absolutely, positively not. Okay, you are always going to have access to this table with the prefixes, so don't worry about memorizing it, but we are going to use it as we talk about measuring and also converting within the metric system. Okay, not really a lot else to show you on this one. All right, again, base units in the middle, and then we can go to the larger units if we go up, and we can go to the smaller units if we move down. Okay, so let's get right into it. The first type of measurement that we want to be able to do using the metric system is to measure length. We know that length is the distance between 2 points. All right, this is big. The SI base unit for length is the meter. How do we measure length using the metric system? We use rulers, we use meter sticks, you might see people walking down really long stretches with those little wheels that turn and measure length, right? So we use these tools to measure length. The base unit for that is the meter, right? So I have a question for you. This is our very first question for this lecture. So let me get through this, and then I'm going to have you guys throw this out into the live chat so that Mr. Wen can check out some of those answers. So I want you to think about this. Thinking about length, what would be the appropriate unit of length for measuring the following? So we're using kilometer, meter, and millimeter. So A, what would be the appropriate unit of length for the thickness of your fingernail? What would be the appropriate unit of length for the distance between your house and HHS? And then what would be the appropriate unit of length for the height of the roof of your house? So use these three options. In the live chat, let's go, if your first name is A through F, let's go ahead and throw some of those answers into the live chat. What would be the appropriate unit of length? I'll give you a minute or two like we did last week, and then I'll come back to you. All right, minute or two, let's see what we can do there. Okay, Mr. Wen, are we getting any answers in there for the appropriate units of length?
We have A is millimeter.
All right.
We have B is kilometer.
All right.
And C is meter.
Okay. Does it look like we're pretty much in agreement for those?
Absolutely. Now they're just rolling in.
Love it.
So we have millimeter, we have kilometer, we have meter. Overall, great job, guys, in terms of the answers that we're seeing.
Beautiful, beautiful, beautiful. Okay, so again, the idea is that if you were going to measure the thickness of your fingernail, the most appropriate unit to use would be the millimeter. If you were going to measure the distance between your house and school, the most appropriate unit would be kilometer. And if you were going to measure the height of your roof at your house, the most appropriate would be the meter. You wouldn't want to measure the width of your fingernail using kilometers. Okay, that wouldn't be the best one to use, and the answer would be pretty crazy. So we want to pick the most appropriate unit to measure the different things in there. Okay, so let's do a live demonstration. So I'm going to show you. I'm going to turn the camera around here in just a minute, and we're going to work through a live demonstration to show you how we would use a tool, a ruler, to measure length in the metric system. Okay, so bear with me for just a second. We're going to measure an iPhone, and we're going to measure a roll of tape. So I'm going to turn you guys around here in a second, and Mr. Wen and I are going to work for that. You want me to put? All right, so here we go. Okay, so we have our roll of tape. I'm going to use a very simple little ruler. Okay. On one side we have millimeters and centimeters. On the other side we have inches. Pretend that doesn't exist because we're not going to use the inches. We're going to use the metric side of the ruler. So something that I want to draw to your attention, and it's a little bit hard to see because we're doing this via the camera. These big numbers, 1, 2, 3, 4, 5, 6, 7, and so on, those are measuring centimeters. So in between each one of those we have a centimeter. These smaller tick marks, okay? And again, it's kind of hard to see, but there's 10 of them in between 1 and 2. Those are measuring our millimeters, okay? So what I'm going to go ahead and do is this. I'm going to put this ruler on one end of our tape, okay? And I'm going to stretch it across to the other side. And what I want you to do, and I'm going to give you this as a little bit of a reference, okay? What I want you to do is estimate, and again, it's not perfect. You're not seeing this with your own eyes. I want you to estimate and put into the chat, what do you think is the diameter of this roll of tape using the metric measurement for length? Okay? So tell us, put that into the live chat, throw those answers in there, and then we'll come back and we'll check it out. So again, go ahead and throw those into the live chat. We'll check that out while you guys are working. And I jumped ahead. I did the tape first, and I'll do the iPhone next. So go ahead and throw those in there.
All right, we got a first response, 11 centimeters.
All right.
We got 10 centimeters.
Okay.
11 centimeters. 11 centimeters. 11, 11, 11.
Love it. Love it. All right, so we're gonna go ahead and jump ahead. But really quickly, one more time. You guys have all used rulers. So we know that we very simply just put our ruler on the tape, and then we measure to the other side there. So the measurement for this one is actually 11.1. It's kind of hard to see over the camera. But if you were right around 11, if you were 11, 11.1, maybe even 11.2, that would be a good measure for the diameter of the tape. Okay, so now I have my iPhone. I have my ruler again. So what I'm going to go ahead and do is I'm going to measure the length of my iPhone. Okay, and there is a case on here, so it's not perfectly easy to see, but I'll use that. So I want you to tell me, and it's right about there. what do you think the length of my iPhone would be using a metric measurement? Okay? So figure out what your big centimeters are. So 14 to 15. So it's going to lie somewhere in between 14 and 15. What do you think that might be? Everybody, doesn't matter last name, but when you think you know what that might be, go ahead and throw that into the live chat. And I'll leave that right there for you guys to see it. Again, not perfect, but it'll work for what we're trying to do. Okay, so go ahead and throw that into the live chat. I'll give you about a minute. What do you think that might be?
All right, we got answers rolling in.
Love it.
We have 15, we have 14 and a half, we have 14.7, 14.6.
Love it.
And great job, guys, on the units.
Absolutely.
I'm seeing all sorts of units. You guys did a fantastic job with that. We have a 14.4.
Great. So if from my point of view, and you guys can't see me, but you can see the iPhone here. From my point of view, if I actually look at this measurement, it is actually 14.6 would be the appropriate measure of length for that iPhone. So again, if you were anywhere between 14.4 and let's say 14.8, those would be appropriate measures for the length of the iPhone. It's not going to be perfect in this situation, but it's good enough to get the point across, all right? So great job. I'm going to turn you guys back around so you can see the board. Okay, and then we'll roll into that. Okay, so what you saw, and I know it probably seems simple, but what you saw is how we use a ruler to measure length. We can do the same thing with a meter stick or anything that allows us to measure length within the metric system. So let's kind of roll on. One thing that we want to be aware of is the idea of precision versus accuracy. So when we are making measurements, and it doesn't matter what you use, it could be a ruler, it could be a scale, it could be a graduated cylinder potentially, it could be a beaker. We want to think about how precise and how accurate we are. So precision is the exactness of a measurement, and accuracy is how close the measurement is to the actual correct value. So we want to keep those things in our head. How precise and how accurate are we being? So I want to give you an example and show you kind of what that looks like. So here's our example. Let me make sure that you guys can see this. We have talking about Highlands High School. All right. So if we were to make the statement, Highlands is in Fort Thomas. All right. That is in fact an accurate statement. Okay. Highlands is in fact in Fort Thomas, but it's not very exact. Because if you were to tell somebody that had never been here, hey, Highlands is in Fort Thomas, they would come to Fort Thomas, but they would have to look around within the city limits to actually find the school. Okay? So accurate, but not exact. Now, if you were to give them this statement, Highlands is at 15 North Fort Thomas Avenue, all right, that's a precise statement, but it's not accurate. You could go to 15 North Fort Thomas Avenue, and you could stand in front of that address and look straight ahead, and you're not going to see Highlands High School. Okay? You're in the right city, okay? So it's precise, you're close to where you want to be, but it's not accurate. Now, what if you told somebody Highlands is at 2400 Memorial Parkway, Fort Thomas, Kentucky? Okay? That is both precise and accurate. That's what we want. In science, we want measurements that are both precise and accurate. So this right here, that's where we want to live as scientists. Okay? Precision and accuracy, we want to make sure that we have both of those. Okay? So a little bit about precision and accuracy. We're going to try to be as precise and as accurate as we can when we do these live demonstrations right now, and then when we start actually measuring things in class. So mass. We looked at length before. Now we're going to look at mass. All right? Mass is the amount of matter that exists within an object. So think of it this way. If we have a golf ball and a ping pong ball, and I don't have one, but imagine that I did. If I had a golf ball and a ping pong ball, those two balls are about the same size. Okay, a golf ball and a ping pong ball. But The golf ball has a lot more matter in it, so its mass is going to be larger. The ping pong ball has a lot less matter in it, so its mass is going to be smaller. Even though they're the same size, they have drastically different masses because they have different matter. Okay? Now, there we go. Okay, so when we think about mass, and we think about measuring mass using the SI system or the metric system, the base unit for mass is the grain. All right, the base unit for mass is the grain. And to give you an idea of about what 1 gram feels like, a paper clip, a normal paper clip that you would get from your teacher is about 1 gram. So that gives you an idea of about what a gram is. Okay, this is super important right here. The mass of an object will not change unless we add or subtract matter from it. So the only way for me to change the mass of a golf ball, right, is to cut it up into smaller pieces or to smash it or break it apart. That's the only way that I could potentially change the mass. Can I change the weight of it? Think back to physics. Sure, I could take it to the moon, right? I could take it into space. That will change the weight of it, but the mass of that golf ball in space is still the same thing. While the weight changes, the mass stays exactly the same. Okay? So it's very important that when we're thinking about measuring using the metric system, that we think about mass as being how much matter exists within something. So how do we measure that? The triple beam balance. Okay? So we use a triple beam balance to measure mass in science class. Okay? Hopefully you guys have seen these before. If not, we're gonna do an example of it, and then we're also going to do a live demonstration to help you out a little bit with that. Okay, so this triple beam balance has some weights on it, and it allows us to measure mass in the metric system. So let's look at an example. Actually, let's do this first. Thinking of the metric measurement for mass, what would be the appropriate unit of mass for measuring the following? And we're going to use kilogram, gram, and milligram. One thing I want to draw to your attention, kilo, milli, those prefixes stay exactly the same. We're just changing the unit. Kilogram, gram, milligram. So, using these three, what would be the most appropriate unit for measuring the amount of vitamin A in an energy bar? What would be the most appropriate unit for measuring the mass of a bowling ball? And what would be the most appropriate unit for measuring the mass of a mouse? If you are G to R, if your last name is G to R, go ahead and throw the answers to that in the live chat, and we'll check those out and we'll go on from there. So a minute, maybe 2. We'll see how quickly you guys get those answers in there. See if you can figure out what the appropriate units for mass would be for those different examples. All right. All right, so see if we can't throw out those answers for the appropriate units of mass. If we're thinking about the amount of vitamin A in an energy bar, the mass of a bowling ball, the mass of a mouse, see if you can let us know what those appropriate units would be. All right, so we got a couple coming in here. Mr. Wen, what do we got?
We have kilogram, grams. We have milligram, kilogram, gram, milligram, kilogram, gram. Oh, they're nailing it. Milligram,
Right
kilogram, gram.
Okay, wonderful. Again, we're trying to think about what would be the appropriate unit if we were going to take the mass of these things. Yeah, the amount of vitamin A in an energy bar, that's very, very small, so we would use milligram. A bowling ball, I'm sure you guys have held a bowling ball before, we would measure that using kilograms, and then the mass of a mouse, a little itty bitty mouse, would be measured with grams. Okay? Now, how do we actually do that? What's a tool that we can use to actually measure it? We're going to use the triple beam balance, and I'm going to stand over here to the side so that I'm not right in front of the screen. Okay? So this is what the part of a triple beam balance looks like that we're actually going to use to measure mass. Okay? So we have 3 parts to the triple beam balance, and I want you guys to be aware of this. In the middle here, we have the portion of the triple beam balance that measures in hundreds of grams. So it goes from 0 to 500 grams. Up here at the top, we have the part of the triple beam balance that measures in tens, units of 10. So it goes from 0 to 100. And then down here at the bottom, we have the part of the triple beam balance that measures in single, 1 unit. Okay, so it goes from 0 to 10. So the way that we use these 3 parts together gives us a mass for whatever object it is that we put on a triple beam balance. Okay, so looking at this, you may or may not have used a triple beam balance before, but if you were to look at this image, what do you think the measure is for the mass of whatever item was on this triple beam balance? So again, in that live chat or on your notes for sure, why don't you go ahead and write down what you think the estimate would be for the mass of whatever object it was that was put on this triple beam balance. Okay, throw that into the live chat. Let's do A through Z. Don't worry about a specific set of students. Let's do A through Z. What do you think the measure is based on this picture for the item that's on the triple beam balance? Let me know. We won't take as long for this one, maybe 30 seconds. What do you think? What do you think the mass would be based on that image right up there on the picture? What do you guys think? And then Mr. Wen will let us know when we get some answers in there.
Alrighty, 37.5 grams, 37.5 grams, 37.5 grams, 37.4 grams, 37.3 grams, 37.3, 37.3, 37.5, 7 grams and 30 kilograms, 37.5 grams.
All right, nice. Okay, so here's what we got. The correct measure based on this triple beam balance would be 37.123, so 37.3 grams. I know it looks like this is kind of maybe in between right there, but if you were really close to 37.3, maybe you had 37.4 or 37.35 or 37.5, that's pretty close. We would probably accept that. But using this picture, that's where we would want to land. So what does this actually look like? Okay, we have a triple beam balance right over here behind the camera. So we're going to turn you around and we're going to actually show how to do this. We'll learn how to use it and how it can actually give us a measure for the mass of an item. Okay, so here we go. We're going to look at the iPhone and the masking tape again. Okay, so let's do this in the correct order this time. All right, so here I have my iPhone, right? I'm going to put that over here on this portion of the triple beam balance. So I'm going to bring to your attention a couple of things, just like the picture. Here in the middle, okay, this weight right here is what we use for the hundreds. Okay, so we can move this side to side to try to determine the mass. In the back here we have the tens, same thing. We can move this side to side to find a measure for the mass of whatever we have. And this one up here, which could be a little bit hard to see, this is measuring the ones, and we can do the same thing for this. We can move it side to side. All right? What order do we go in? Okay? Do I just come up here and start moving stuff like this and try to figure out if that's the correct way to find my mass? Does that work?
No, that does not work.
All right. So we wouldn't want to just do that. We have a specific set of steps that we want to follow. Okay? And the way that we want to do it is we always want to start with the hundreds. All right? It's kind of hard to see, but there's some notches on the triple beam balance that this fits perfectly into. Okay, so the first thing that we want to do is we want to move this, okay, until this right here drops below the other line. Okay, so I'm going to do that. So I went from 0 to 100. It didn't move. I go from 100 to 200. It didn't move. I go from 200 to 300. Oh, it moved. So what I have to do is I have to move back to the most recent one. So when I go back to 200, it pops up. So that's telling us that the mass of this is below 300 grams. Okay? So now I'm going to come back to here. So I'm going to go to 10. It hasn't moved yet. I'm going to go to 20. Oh, it fell down. So I'm going to go back to 10. Okay, make sure that clicks there. And now I'm going to come up here to the ones, and I'm going to slowly move this. Oh, see, it fell down, so I need to go back a little bit. That's pretty close. Mr. Wen, you think that's good?
That looks really good.
Okay, so here we have our hundreds. Here we have our tens. Here we have our ones. What do you guys think? And go ahead and put that in the chat. What do you think the measure for the mass of my cell phone in grams would be? Go ahead and throw that into the chat, and we'll see where you guys are with that, and we'll go from there. Okay, let's open this one up to everybody. What do you think the mass of the cell phone is based on the reading on the triple beam balance? Okay, I know it's a little bit difficult to see. So what do we got there? All right, and I'm going to hop back. So this is for everybody. What do you think that measure? Oh, okay. We still got some coming in from the last one.
We got 213.9, 213.9, 214, 213.9, 213.9. Bunch of 213.9s.
Love it. Bunch of 214s as well. Okay, absolutely. So if we look at this, okay, you guys are right on. So we have 200 plus 10 plus 0, 1, 2, 3. And this is about 3.9. So that's, I would say, right around 213.9. If you were right around that, 213.8, 214, you're spot on. Okay? So let's do one more, and then we'll go from there. So one thing that I'm going to draw to your attention is, before I can take the mass of another object, I have to move these all the way back over to the side to basically re-zero my triple beam balance. So I'm going to do the tape. Okay, so we're going to do the masking tape this time. And again, I'm going to start with my hundreds. So the very first thing that I'm going to do is I'm going to move this over to 100, and I want to see what happens. Oh, so it dropped all the way down. So I'm going to have to move back. And now I'm going to do this. 10, 20, 30, 40, 50, 60, 70, 80, 90. All right. So it fell down when I got to the 100. So I'm going to have to go back to the 90. Okay. And now I'm going to come up to my ones, and I want to go ahead and start slowly moving this one until I start to get my measure for the mass of the tape. So I have a little bit further to go. That might be too far. It's kind of hard to do it with. All right, I think that's pretty close. Don't you think, Mr. Wen?
Absolutely, good job.
Okay, so let's look at our triple beam balance now. So we're doing the masking tape. What do you guys think? Here's our 100. It's on 0. Here's our 10s. It's way out here. And here's our 1s, somewhere in between there. So in the live chat there, let's do S through Z. So the end of the alphabet, S through Z. Go ahead and throw it out there. What do you think the measure of the mass of the masking tape would be based on what you see on the triple beam balance right there? Okay, and again, I know that it's not super clear but we can hopefully still get an estimate of the mass. S through Z, what do we think?
All right, we're getting some in.
All right.
93.4, 96.4, 96.4, 96.4.
All right, so it looks like most of us are falling right around
The 96.4.
96.4. Okay, so again, if you look at this, we know that we had no hundreds, so that was 0. Our tens was on 90. And then again, it's kind of hard to see, but it's right in between 6.4 and 6.5. So anything in the 96.4 to 96.5 range would be spot on. Okay, so using that using that triple beam balance to measure mass, awesome job, guys. Okay, so now I'm going to turn you guys back around. We're going to move on to our next unit of measure. Okay, which is volume. So what I want you guys to do is check this out. I'm gonna hop back up there and we'll talk a little bit about volume. Okay. So we've looked at length, we've looked at mass, and now we're going to talk a little bit about volume. So volume, a good definition, volume is the amount of space contained within an object. Okay, and when we have regularly shaped objects, right? So over here we have a cube. The way that we can calculate the volume is by using this formula right here. Volume is equal to length times width times height. As long as we can measure the length, the width, and the height, we can find out the volume. Okay? That's not always the case if we have irregularly shaped objects like spheres, okay, or a rock that you might find outside your house. Okay? So we can't always use this exact formula, but there are different types of formulas and different processes that we can follow to find the volume. But it's always going to be the amount of space contained within an object, right? In this case right here, we measure the volume in cubic centimeters, okay? So we have centimeters times centimeters times centimeters. That gives us cubic centimeters. That is also a metric unit for the measure of volume. Okay, we'll see that we also use things like liters, milliliters, centiliters. So we're going to see that in a second. But you can absolutely measure the volume of something using cubic centimeters. Okay? So what is the base unit for volume? The base unit for length is the meter. The base unit for mass is the gram. The base unit for volume is the liter. All right? And how do we measure the liquid volume of something? We use graduated cylinders. Okay, so a graduated cylinder is just a tool that we can use to measure the liquid volume of something. Okay, and we'll use these a lot in class this year, so it's very important that we get an idea of what that looks like. Now, when you use graduated cylinders, there are a couple of things that we need to be aware of. The first, and probably the most important, is that when you pour liquid into a graduated cylinder, it actually creates this curved portion right here that's called a meniscus. Why does that happen? Well, there are adhesive forces between the liquid, and let's say it's water, between the water and the outside or the actual cylinder part of the graduated cylinder. So that causes the water to kind of grab onto the outsides and it creates this nice little curved meniscus. Why is that important? Well, in order to get the correct measurement for liquid volume, we have to measure from the bottom of the meniscus. So we don't measure from the top, we measure from the bottom, and that will tell us how much liquid volume we have. Right? So let's do a quick little example there. Here's a picture. All right? Over here we have a zoomed out picture of a graduated cylinder. It has a liquid in it. Let's just say that it's water. And here we have a zoomed in picture of that. So what I want you to do, and we'll talk a little bit about how to do this, what I want you to do is estimate the volume. Okay? So in the live chat, again, we love that you guys participate with us. We want to use that feature. A through Z, let's have everybody do it. What do you think the volume of that liquid, water, in that graduated cylinder would be. And then we'll come back together and we'll talk a little bit about it, and then we'll check out our live demonstration. So, in the live chat, everybody, what do you think the measure is for the volume in that graduated cylinder? All right, do about a minute.
Alrighty, we're starting to get some answers. 40.3, 43 cubic centimeters, 43 and a half liters, 43 liters, 43 liters, 43 milliliters, 43 liters.
Okay. So a couple of things that I should probably remind you of. We know that the SI unit, the base unit, is the liter. When we use graduated cylinders, the majority of the time we're going to be measuring in milliliters. So I probably should have made a mention of that so that you could get the correct unit for that. Okay? How do we find out the actual value? So if we look at the zoomed in picture here, we have two very large numbers. Okay? So we have 50 and we have 40. So this is basically telling us, just like on a ruler, that the maximum that we could potentially have would be 50, because this is in between 40 and 50. Okay? So how do we determine what the actual volume is? What we do is we take our top number, which is 50, and we subtract our bottom number, which is 40. What does that give us? 10. All right? So we know that there's 10 units in between these two numbers. Then we look at the individual tick marks, and we figure out how many tick marks there are in between our two larger numbers. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 tick marks, and there was 10 units in between that. So that means that each tick mark is actually 1. Okay? If we're using milliliters, what we would then do is we would say 41, 42, 43. So our measure would be 43 milliliters, give or take a little bit. So 43 milliliters would be our correct measure for the volume of that liquid in that graduated cylinder. Okay? So what we're going to do is I'm going to give you the opportunity to see this live, or as live as we can be. And I'm going to want you to do the same thing. Look at the level of the liquid in the graduated cylinder, and then we're going to go ahead and see if we can't try to estimate what the volume of those liquids are. So what we're going to have is we're going to have 3 graduated cylinders, graduated cylinder 1, 2, and 3, and we're going to actually look at the liquid inside those graduated cylinders to see if we can estimate the volume. So hang with me for just a second as I jump over here. Got to put my mask back on. All right, so here we have our graduated cylinders. Okay, and I'm going to zoom out just a little bit so that you guys can see. So we have 3 graduated cylinders. Here we have cylinder number 1, so right here. This is number 2, and this one way up here is number 3. Okay, so let me zoom in a little bit on graduated cylinders 1 and 2 first. Okay, so what I want you to try to do, and I'm gonna do my best with the focusing, and I'll maybe kind of move them around so that you can see the level. Okay, so what I want you guys to do in the chat, and let's go back, let's go middle of the alphabet. Let's do L through Q. So if your last name is L through Q, what I want you to do is go ahead and estimate what you think the volume, and we're going to use milliliters. So I want you to estimate what the volume of liquid in these 2 graduated cylinders would be. Again, this is number 1 right here. This is number 2. So I want you to think about what is the large number above the meniscus and what's the large number below. What is the large number above the meniscus and what is the large number below? And then make your estimate based on that. So, give you about a minute, maybe 30 seconds. What do you think the volume of graduated cylinder 1 would be? What do you think the volume of graduated cylinder 2 would be? And it's just an estimate. You're not viewing these with your own eyes. It would be way easier in real life, but let's do the best we can with what we got. So graduated cylinder 1 and 2. What do we think? Again, I know it's a little difficult to see. There's 1, and there's 2. Okay, let's see if we can get maybe 1 or 2 answers, and then we'll go on to graduated cylinder 3.
All right, our first answer, 6.6 milliliters and 18 milliliters.
All right.
6.7 milliliters and 18 milliliters. 66 milliliters and 18 milliliters. I'm guessing 6.6.
Absolutely. Okay, wonderful, guys. So again, I know it's not perfect, but if you look over here, we are right at 6.6 milliliters, so that would be the reading for graduated cylinder 1, and graduated cylinder 2 is in fact 18 milliliters. All right, great job. So let's do our last one. Sorry about that. Graduated cylinder number 3. Here's our image. Let's do everybody, A through Z. Okay? Look at the level of your liquid. Look at the big number above the level, which is 50. Look at the big number below, which is 40. So then your reading for the volume of the liquid is going to fall somewhere in between those two numbers. So what do you guys think? A through Z. Throw them out there, and then we'll move on. What do you think the volume of the liquid in that graduated cylinder would be? What do you think? All right, what do we got there?
All right, 47, 48, 47, mostly 47s.
Okay, I love it. Again, it's not perfect, but it is actually 47. Okay, so 48 would be okay. I would even take 46. But with your own eyes, it would be a little bit clearer. So that would be the volume of the liquid in that graduated cylinder. Wonderful, wonderful, wonderful job, guys. Thank you, thank you. Let's go ahead and move on. Bear with me as I get the camera set back up here. I know it's going to bounce around a little bit. Okay, so here we go. So we had length, we had mass, and then we had volume. Okay, so let's look at one more. Actually, let's do a fun fact really quickly. Okay, when the metric system was created, they decided that 1 cubic centimeter of water would equal 1 milliliter of water, and that 1 milliliter of water would have a mass of 1 gram. So in fact, 1 cubic centimeter of water is equal to 1 milliliter of water is equal to 1 gram. So we talked a little bit earlier about how it's so easy to measure and so easy to convert within the metric system. This is just another layer of information about the metric system that helps you with that. Okay? Everything's connected in one way or another within that metric system. So here's our base units again, just another review. Let's see if I can get you a little closer there. Okay? So we have our base units. We talked about length, mass, and volume. The base unit for length is the meter, the base unit for mass is the gram, the base unit for volume is the liter. We do have a couple of other measurements that we make, temperature and time. Okay? For temperature, we measure using Celsius or Kelvin. The large majority of the time in biology class, we're going to measure using Celsius. Chemistry, they're probably going to measure using Celsius. When you get into things like physics and maybe some other disciplines, you might use Kelvin. But we're going to use Celsius for our measurement, and then time is measured in seconds. So again, this is just a beautiful little picture to give you an idea of those base units. So let's talk about temperature. We talked about length before as the units that we in the United States use for measuring length. The same is true for temperature. We use this thing called Fahrenheit. All right, 32 degrees Fahrenheit, that's when water freezes. 212, that's when water boils. Why those numbers? I don't know, we don't know. Okay, somebody just picked those as that's freezing and that's water boiling. The metric system is way easier. Okay, here's kind of a little cheat sheet. If it's 30 degrees Celsius, it's hot. If it's 20 degrees Celsius, it's nice. If it's 10 degrees Celsius, it's chilly. And if it's 0, it's ice. Okay, it's frozen. So using the metric system to measure is a lot more user-friendly. It's a lot easier to use than the system that we use. Okay, Kelvin, I'm not going to spend a lot of time on Kelvin. Kelvin is another one, like I said, that scientists will use. There's no negative numbers, and when you get to 0 degrees Kelvin, that's as cold as anything could be. Absolute 0. Right? So that brings us into the last thing that we're going to talk about. And that is, converting within the metric system. Okay? So a couple of big things that I want to bring to your attention. We're going to do a little bit of conversion, and I'm going to let you guys go. Okay? Here is this nice little spectrum of the prefixes or the units within the metric system. So we have kilo, hecta, deca. Here's our base unit right here. Meter, liter, grams, second. Here we have deci, we have centi, and we have milli. You are always going to get that, so there's no need to memorize that. Right? Ultimately, what we want to be able to do is we want to be able to easily change the units of a measurement or convert them within the metric system. So we have our spectrum there. These two things are also very important up here. Okay? If we are moving from a smaller unit to a larger unit, okay, so if we're going from centimeter to kilometer, we're moving from smaller to larger, so we're going to move the decimal point to the left. If we're going from a larger unit to a smaller unit, so if we go in the opposite direction, from kilo to centi, we're moving in the right-hand direction, so we're going to move the decimal place to the right. How many times do we move the decimal point? However many spots there are in between the two units that you're working with. So if we go from kilo to centi, we're going to move the decimal place 1, 2, 3, 4, 5 spots to the right. Okay? So let's do an example. I'm going to have you guys, we're not going to go through all of these. I do want you to try these in your notes, but we're going to do an example here to see how we can do this. Okay? So this measurement right here, I understand that's probably a little bit hard to see. This is actually 422 centimeters. Okay? So if we want to convert 422 centimeters to meters. So we're going from centimeters to here. This is an M. Mr. Wen, do we just go right here to this M?
No, not at all. That's smaller, Mr. Ewald. That's smaller than centi. That's milli.
Oh, that's right. So when you go to the right, you're getting towards the smaller units. So this would actually be millimeter. So I need to find the other M. Oh, it's right here. Okay. So here's our base unit. So we will in fact go from centimeter to meter. So we're moving 2 spots to convert from centimeters to meters. So really quickly, 30 seconds. What do we think this value right here is going to be for how many meters are in 422 centimeters? 30 seconds. Everybody, A through Z, throw that into the chat and see what we can find. What do we think? 422 centimeters to how many meters? Okay. All right, so we'll let those come into the chat, but here's how we're going to do it. So we're going from centimeters to meters. So we're going to move that decimal point 2 spaces to the left. So we're going to take that decimal point, we're going to go 1, 2, so that means that we would have 4.22 meters.
Oh, wow. And that's what we see there.
Spot on.
Oh, so many 4.22 meters. Good job, guys. Don't forget the unit.
Absolutely. Make sure we have those units in there. Okay, I'm going to do one more with you, and then we're going to move on to the last part, and we'll roll from there. Okay, let's do this one together. So this is 69.63 liters. Okay, so this is liters. So if we are going from 69.63 liters to milliliters, that means we're moving from here, our base unit, to down here because milliliters are smaller. So we're going to go 1, 2, 3 decimal places, and we're going from larger to smaller, so we're going to move to the right. So that would mean that we would move it 1, 2, 3, we'd add a 0, 69,630 milliliters would be our measure for that. For the sake of time, go ahead and fill out the rest of these in your notes. Okay, don't worry about putting them in the live chat or anything like that. If you're struggling, contact your teacher. Let them know that you need a little bit of help with the conversion. All right. So let's move on so that I can get you guys out of here. Okay. So the last thing that we're going to look at is what do we do if we don't exactly have the factor of 10? So we're not going from kilometers to centimeters or kilometers to meters. What do we do if it's all mixed around? So we have Vinny who emptied his piggy bank. He had 22 quarters, 7 dimes, 9 nickels, and 75 pennies. How much money does he have if we want to find dollars? Okay, so the unit that we're interested in is dollars, but they're giving us 22 quarters, 7 dimes, 9 nickels, and 75 pennies. So the very first thing that we have to do, okay, so here's our 22 quarters. The very first thing that we have to do is we need to get quarters to dollars because that's the unit that we want. So how do we do that? Well, $1 is equal to 4 quarters. Why do we put it this way instead of the other way? Well, we want to be able to cancel out the quarters, that unit, so that we're left with the dollars. So the unit that you want to cancel out, that you want to get rid of, always needs to go in the denominator, the lower portion of this. Okay? So we have 22 quarters, $1 is equal to 4 quarters, and then we just multiply that, right? So 22 times 1 gives us 22. We're not multiplying 4 by anything, so that goes there. 22 over 4 would be $5.50, $5.50. Okay? So we would do the same thing for dimes. $1 is equal to 10 dimes. We would multiply that. 20 nickels is equal to $1, so we would multiply that. And then 100 pennies is equal to $1, so we would multiply that. Okay? So we change the units from these. They're all in dollars now. So now we can just add this bad boy up and figure out exactly how much money Vinny had. Okay? If Vinny was a 4-year-old like my daughter, that's a ton of money, right? If Vinny's a little bit older, it might not be a ton of money in that piggy bank. Okay? So that's how we can convert from one unit to the next when it's not the base unit of 10. Okay? Conversions are very important. We're going to do a lot of practice with that this year. So that leaves us with this, guys. Okay? A couple things that I want you to remember as we get ready to sign off for the day. Number 1, make sure that you turn in your questions. Okay? Make sure you take a picture if you're in Mr. Wen's class. Make sure that you fill out the discussion board if you're in my class. Just get that turned in before the end of the period, or even if you're in my class at the end of the day because we ran a little bit late. Just make sure you reach out to me. Check Schoology for instructions on how to do that. Check Schoology to see whether or not you have an extra assignment in there, a little bit of practice. I know that I have metric measurement practice. I know that Mr. Wen has the same thing. So make sure that you check Schoology to figure out what that is and when that's due. Mine will be due on Thursday. Mr. Wen's will also be due on Thursday. So make sure that you check that out. And then the last thing, pay attention to any information that comes from your teacher about our next time-bound Teams meeting. Okay? Some of them might be small groups or individual or even large groups. Just make sure you listen to your teacher for that. Okay. Thank you, thank you, thank you. I know again it went a little bit longer than I had originally planned. Thank you for participating. Thank you for logging on. Reach out to me, reach out to Mr. Wen if you have any questions about anything, and we'll see you during those time-bound events later in the week. Okay. Have a great day, guys. You are awesome. All right, we're good.